Alright, looking at the 2003 AP Calculus exam question number 1. This was on the ABNBC exam. This is what I call a rate in, rate out question that has been very popular in recent years, and you will need a calculator for this one. So this problem, we have a gravel processing plant, and it tells you that gravel is arriving at the rate, and pay attention that this is a rate that gravel is arriving, is given by the function g. We're on the interval 0 to 8. They give us an amount at the beginning at 500 tons at the beginning of the day, and then they tell you that gravel is being processed at a rate of 100 tons per hour. So in the given information, we have a rate that something is arriving, which I will call the rate in. So rate in, the rate that gravel is arriving, is the function g. So I have g of t, and I have stored that in my calculator for F1, and my rate out would be the rate that we are processing the gravel is a constant 100 tons per hour. Now, even though that's a constant, I still took the time to store that in my calculator for F2. Then they tell us that the amount of gravel at the beginning of the day is 500 tons. So what I will usually do is I'll make a note to myself that A of t is the total amount of gravel. I'm defining that myself. And that the amount at time 0 is 500 tons. Okay, pay attention to the intervals. All functions are operating from the interval 0 to 8, so sometimes it will flip that up on you. Then question A, find g prime of 5 and then interpret the answer. So g is given, g prime of 5. You are expected to use the derivative at a point command in the calculator, so I'm just going to punch that in the calculator real quick and give you the answer. There we go. We get an answer of negative 24.5875. You must be accurate to the third decimal. And for this problem, you have the option of rounding to 0.588 or truncating, which is the option I'm going to choose, which is when you just stop writing after the third decimal. So there's your value. Then it says interpret that answer, and don't overcomplicate this, but we found out that the derivative of g is negative, and my thought process is that g is decreasing. A negative derivative means the function decreases, but instead of saying g decreases, I have to put in words what g represents, and g represents the rate at which unprocessed gravel arrives. So I'm going to write the rate unprocessed gravel arrives is decreasing at 24.587 at time t equals 5. There. So the rate is decreasing at that rate. Notice I left the negative off because the negative is implied in the word decreasing, and the units, g was already measured in tons per hour, so when I did the derivative of that, that introduced another unit of hours, so the unit is tons per hour squared. And in these, interpret in the context of the problem questions, you need to make sure that you restate all values, all numbers that were involved. So restate the actual answer of 24.587 as well as the time at which you are estimating it. So question B, find the total amount of unprocessed gravel that arrives during the hours of operation, which would be from 0 to 8. So here we want the amount that arrives. The function given, g, is the rate that gravel arrives, and so the amount that arrives is simply going to be the definite integral from 0 to 8 of the function g of t. The area under the rate does give the total amount. The fact that we started with 500 tons does not matter. We do not have to use the initial amount because the pile that was there at the beginning of the day does not affect how much was added to the pile. And that's what they're asking, how much was added, how much arrived over the interval. And this is one that, again, we will just punch in the calculator and write down the answer. There is our answer. And again, make sure you include the third decimal. They did not in part B ask you to specify units, but that should be a given. Anytime units are provided, you should always provide units in your answers. Sometimes it counts against you, sometimes it does not. So question C is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5, and show the work that leads to your answer. Okay, there are two ways to approach this problem. One of them is to look at the rate in and the rate out separately, because we are now talking about the pile of gravel at the plant. This is going to be dependent on both the rate in and the rate out. So I could find the rate that gravel arrives. I could find G of 5. I could throw that in the calculator. I already know the rate out. The gravel is processed at 100 tons per hour. That was given, so we don't have to compute that. So I'm going to go to my calculator and I'm going to find the value of G of 5, and don't confuse it with part A. Part A was G prime. We're not going to import that. We need to compute G of 5, so let me do that really quick. And we get 98.141, and that's going to be measured in tons per hour. And that's how quickly it arrives, and then it's processed at 100 tons per hour. And so I could simply compare those two. It's arriving at 98 and being processed at 100. We're processing it more quickly than it is arriving, so because the rate out is greater than the rate in, that means the overall amount is decreasing. And so the amount, therefore, the amount is decreasing. It says show the work that leads to your answer. This might be sufficient. Boy, that work decreasing looks like crap. But I'm going to go one step further. I'm going to say amount is decreasing because G of 5 is less than 100. And I have the work to support that statement. And so that would be one way of doing this. And the other way to approach this would be to go back to what I defined to be the overall amount. A long time ago I defined A of t to be the overall amount of gravel, and they're asking us if the amount of gravel is increasing or decreasing. In other words, is A prime of 5, the derivative of the overall amount, is that positive or negative? And so if we can figure out if A prime is positive or negative, that would also answer the question. The problem is I don't have a function defined for A, but if you know the rate in and the rate out, the overall rate of change will always be the rate in, which in this case is G of t, minus the rate out, 100. And so if I define A prime to be G of t minus 100, then I can find A prime of 5, which will be G of 5 minus 100. And when I throw that in the calculator, we're going to get an answer of negative 1 point something. Negative 1.859 to be exact. That would be measured in tons per hour. And because that is negative, the overall amount is decreasing. Both of those should be acceptable approaches. Probably easier to look at them separately. The rate in is less than the rate out, so it makes sense that the overall amount is decreasing. But both of those should be fine. And then finally, go back. Finally, the overall, the number D, what is the maximum amount of unprocessed gravel? So this is your extreme value theorem question, and anytime you want a maximum, and we are on an interval from 0 to 8, you want to consider the endpoints and the critical numbers. So my ends are at 0, 0, and 8. And my critical numbers are going to be when the overall rate of change, because we are looking for the max of A of t is equal to 0. And this goes back to, I defined A prime to be G minus 100. So now I could say I need G of t minus 100 to equal 0, or I need G of t to equal 100, and that's going to give me my critical numbers, which would be my other candidate for the extreme value theorem approach. So I'm going to solve that in the calculator graphically. And when I solve that, I got a critical number of 4.923. So now to find out when the max occurs, or in this case what the actual maximum amount is, I need to find out what my amounts are at the beginning of the day, which is given. That was, it's way up there somewhere, I think it was 500. I'm doing that off memory. I'll scroll up and check that in a minute, but I'm pretty sure it was 500 tons. Then I need to find my amount at the critical number, which I've defined as 4.923. I've stored that in my calculator. And so I could find my amount at time A, and then I need to find my amount at time 8. And your overall amount is going to be your initial condition, 500 plus, and then we're going to measure the area under the overall rate of change, which is A prime of t. Now, I have defined, a long time ago, I defined A prime to be G minus 100. And so I may go ahead and just write G of T minus 100. That is my overall rate of change. And I'll do the same thing down here. A of 8 is going to be my initial amount plus 0 to 8 of G of T minus 100. We will throw both of those in the calculator to see which one gives me the highest amount, and that will be our answer. And here are your amounts, and it turns out that the maximum amount is 635.376 tons. Always make sure you answer the question because they frequently ask you at what time the maximum occurs. This time they actually want the maximum amount, so the time occurring at 4.923 is really not part of the answer. The answer is the max amount of unprocessed gravel is 635.376 tons. If you want to kill it dead, you could say at T equals 4.923 hours, but you don't have to specify that because, again, they didn't say at what time. They said what is the maximum amount. That's your answer. For the justification, if it's an extreme value theorem question, the justification is showing that you considered all of your candidates, your endpoints, you found the critical numbers, and then you found the amount at each of the candidates, and you just simply choose the one that is either the max or the min, whatever is being requested. So there is the end of the 2013 number 1 AP Calculus question.